Hi guys, good evening everyone. This is Ashank David, and in today's video we are gonna talk about linked list concept DSA. And as you have already seen me before, every Saturday we come live on YouTube and we study about DSA, data structures and algorithms. So let's continue talking about it and understand about how it is gonna work. Alright, so let's continue and let's start with our today's concept. In this live session, again we are going to do data structures and algorithms in C++. Let us continue and understand how it is done. Alright, so let's start. So here in this case, in the last class, as you can see, we have understood about this linked list concept. So we will quickly revise it once and we will continue from where we left, and let's begin. So let's welcome to Coders Arcade guys, and let's start. So if you haven't subscribed to our channel before, I do want to tell you about like, share and subscribe, and don't forget to press the bell icon also so that you won't miss any future updates. So let's start. So basically in today's class we are gonna see linked list concept, as we have already understood about this in our previous sessions. We were doing linked list from so many classes. So let's continue and finish off this linked list concept today. So in this case, what we are going to do is today understand how this program was working. So let's continue. So guys, in the previous live sessions, I have already explained you about what is this linked list, how it works. It is a one type of data structures, and how linked list look like. Let me open up my Windows whiteboard, Microsoft whiteboard, and let's get started. I'll continue from where I left, and let's start. All right, so if you remember, we were on this. Wait a minute guys. Yep, here we are actually. So let me explain you what is it all about. So what you are seeing here is a linked list. Here we were doing this. Let me just remove this all. Okay. All right. Okay, all right, understand. This is a linked list, and remember guys, this is the entry level data structure which is asked in interviews. So we need to focus on to this more. Again, I'm saying, if you haven't watched our previous videos, you have to go back and understand about pointers, dynamic memory allocation and all of that, and that is the prerequisite of this live session. So make sure that you remember all these things. Object oriented programming, on the other hand, is very important in this concept. All right, let's get right into the concept and let's understand. So this is what our linked list looks like. This is how our linked list looks like. I told that day only that number one point, there are different kinds of linked list. The very first one that we have understood was singly linked list, then we had doubly linked list, and there are many different types, but these are the two major types that we are focusing on to right now. And the example that I have given you right now, this is a type of a singly linked list. Okay, generally in a singly linked list, what happens is that your node is divided into just two parts, and in these two parts, here is the place where we store the data, and here is the place where we store the link or the connection to the next node. We are revising this again guys, so if you are not revised, please understand this really well. In this case, actually this was our linked list. If you remember, I had created this as a linked list. You see, this was the linked list. This was the original linked list actually. This is the type of singly linked list because we have data and address. This is how a linked list looks like. This is your node. This is square, what you are seeing is called as node. This head, what you are seeing is a head pointer. Okay, and these are the links. Okay, links connecting all the different nodes. It is a list of nodes connected with a link, hence called as linked list. Okay. Now, in this case, if we see what is it all about, the basic property of this is that you see this is our first node, this node is connected to this node. Now, you see what is this? This is the address. What you see, this is the address. This 2187 is the address of this node. Similarly, this 2819 is the address of this node. Why? What is this? You see, if I explain you about the differences in the linked list and arrays, we have understood this really well before. If you compare an array with a linked list, you see array is one big allocation of memory. One single large block of memory is allocated in an array, which is partitioned into many different parts, and hence the array size is fixed. Am I correct? But in this case, linked list is not one single allocation. Every single data has its own memory allocated, which makes it a dynamic data structure. And if I say that every single node has its own memory allocated, it will have some own address, and that address can be pointed using a pointer. What did we learn in the pointers class? Pointer is a variable which points to another memory location. Am I correct? So, in this case, this node has its own memory allocated, and if it has its own memory allocated, it will have its own memory address. Similarly, this also has its own memory address, this also has its own memory address. So, this makes linked list as a dynamic data structure. So, linked list does not have a fixed size. Linked list can take up your whole hardware storage, and it can have n number of nodes. So, it is a dynamic linear data structure. Linear data structure. Why linear data structure? Because it is connected in a straight line in a linear format. Your arrays, stacks, queues, linked lists, these are all linear data structures. But if we talk about trees, trees, heaps, graphs, these are all non-linear data structures. But we are going to talk about them later on. But in today's class, let's understand about this one. Guys, remember, we are still doing revision. We have not finished up our revision, so I am going to take up some time into the revision, and then we are going to cover. You have understood this linear data structure, dynamic data structure. Now, in every linked list, the nodes is divided into two parts. One is data and one is link. Data can store any type of data. Well, link is the place where the address is stored, where it tells this node that it is connected with this node. So, for example, see here, this is our first node, this is our second node. This first node's next pointer points towards this whole node, which tells that this node is connected to this node. All right. So, in this case, what happens is that this is our next pointer and this is the data. This is what? It is a next pointer storing the address of the next node. I hope so that this is very much clear and you have understood this really well. Fast forwarding this. What is this, guys? Can you tell me what is this? It's a head pointer. Head pointer is very, very important concept inside a linked list, because this is the starting index of the linked list. If head is null, then there is no linked list available. If head pointer in itself is null, then there is no linked list. But if head pointer is storing any data, that means the linked list is present. So, this is our head pointer, which will always point towards the first node in the linked list. Clear? Very good. Now, let us move on. So guys, I hope so that you have understood the basics of linked list, and this is what we have done in our previous classes. In just latest previous class on last Saturday, we did one function, and can you tell that function? We did insert at head function. We did insert at head function. Okay. Now revise that logic quickly guys, so that today's class you will understand very well. The logic says, if you want to do insert at head, what do? Imagine this is the given linked list. Now I am asking you to insert the head, insert the node, insert a new element onto the head. You see guys, there are three things that you can do on any linked list program. First is insertion, second is deletion, third is traversal. Okay. The first is insertion. Insertion can also be done in three ways: insertion at head, insertion at a particular position, and insertion at tail. Okay. Either you can insert on the very first place, or you can insert at any particular position in between, or you can place a new node at the tail. Three ways of insertion. Similarly, very similar to that, deletion also can happen at head, at a position, and at the tail. Traversal means just traveling. Traversal is just traveling from one node to another. That is one single operation. Well, I hope so that this is also very much clear. And in the last class, we have understood insertion at head. Let's quickly revise. How do we write the code for this? But before guys, I come to that point, let's go back to our program and understand what I have written. Let's quickly see here guys, everyone. Started with hash include stdio.h. You know what it is, using namespace std. We have already discussed about this. Now, object oriented programming is the key guys. Now I told you that linked list is a dynamic data structure. It can have n number of nodes. When it can have n number of nodes, imagine if you are writing one node and one node takes 5 lines of code. Now imagine there are 1000 nodes and one node takes up 5 lines of code. So will you write 5000 lines of code? Not possible. This is where we use object oriented programming. You created a class node, and in the public section of that class node, the attributes were int data and node star next. What is this? See here, this is one node, 10 is the data, 2819 is the next pointer. We know this diagram. So to create this node, we designed a blueprint. And this is that class node. A node will contain data and a next pointer. Now guys, next is a pointer and of type the same node class. Why so? Because this next pointer is pointing towards the next whole node, and whole node is also created using the same class node only, no? Understood a point? What I am trying to say? I am saying that node star next I have written. This is a pointer which is pointing towards the next coming node. Imagine why I have taken a node star as the data type of this pointer. I could have created int star next, or I could have created float star next, but why have taken node star next? Because you see, one comment is coming. What is the address of the first node? So Ritesh, what is the address of the first node? I'll explain you. You see, the story is very simple. You will see head. If the head is null, that means there is no linked list. And if the head is not null, that means there is a node. Well, you will never get to know what is the address of the first node or the second node or the third node. We are playing with the pointers here. Understood? So we are imagining there is no linked list right now. Imagine there is no linked list right now. I'll show you what I want to say. Imagine you have no linked list. I say that my head pointer is null. Okay, listen to this. What I am saying is, when I say that head is just a pointer, actually, head is just a pointer. Every linked list, either it is a doubly, singly, circular, or whatever linked list in this planet, it will start from head. What is head? Head is a pointer. What is the job of head pointer? To tell where is the first node. And if the head is null, that means there is no linked list present in the memory. But if head contains some address and we don't know that address, I don't know the address because the node is never created. So head is right now null. If I want to insert my first node and if I want to start creating this linked list, I need to start creating a node and inserting at head. So our first function that I told you, insert at head, will be used here. Correct? How? You need to first step create a node. And when you create a node, as I told you, node in itself is an entity which will have its own memory. So you will have to dynamically allocate the memory using malloc or calloc. Understand the point? Unlike an array, see, understand this. An array is one single large block of memory which is partitioned. So array uses one single memory allocation. So the whole array has only one single address, but multiple elements are stored into it. So the size is always fixed in array. You cannot increase or decrease the size. But the perk with linked list is that every single node or data has its own memory allocated. And when this happens, each and every node has its own memory, means it has its own address. So when I will create the node, at that time the address will be given to that node. Understood? And how does this address will be given? By dynamically allocating the memory using a DMA or dynamic memory allocation. Here we will use malloc, calloc, realloc. If you remember C programming, you did not have the concept of classes there. So you used to say struct node. And do you remember writing this? Struct star node equals to malloc of, not malloc, equals to node star malloc of size of, what is this? You were creating a node in DSA in your college, but you were never taught C++ and DSA together, so you did not learn the easy way. You learned the hard way, which is malloc. This is C++. In C++, you can use malloc, but nobody uses it in these days. Malloc is a legacy concept now. In C++, we have malloc and calloc, and realloc is replaced by new keyword in C++. Remember this. So if you have forgotten malloc, don't worry, forget it. Don't forget it for placements though, because this is asked in interviews. Okay, but remember it. But you see, one thing, new keyword is replaced now, has replaced malloc and calloc and realloc. So how do you create? Rather than writing this line, what do you write? You say node class. You guys know object oriented? So we start by creating our node class. You see, class node, and in the public section of that class We have initialized their two attributes, that is int data. A node is what? A node will look like this, no? Data and a next pointer, correct? So I have said class node, int data, node star next. This is a pointer which will hold the address of the next upcoming future node, the second node. So what will be the data type of this? The class itself. Why? Because you see, this node, this is what? You see, this is what? This is a next pointer, this is data, this is next. This is pointing towards the new upcoming node. So the address of the new upcoming node is stored here 2819, 2819. Understand my point? How this node is created? This node is also created with the same class, no? Understood? So what I am saying to you is that the next pointer will have node star as its data type. I hope so that this is very much clear. Understood? Now, how do you create the first node? You see, this is our function which we have written in the last class. Look here. Look here. Insert at head. In C++, if I want to create a new node, node is a class. To create a new node, you will just instantiate the class, create the object of that class, and you will have a physical node in your hand, right? How do we create objects in C++? Node star n. Okay, don't get confused here. Say suppose, let me just take you to another example here. I don't want to confuse anybody here. So what I'll do is I'll create a new let's say demo2.cpp. Okay guys, one thing, hash include iostream using namespace std, and I said here int main. Let's see this int main later on. I said class demo. Okay, how do I create the object of this class demo? I'll say demo and the object name. That's it in C++. By the way, this is int. Okay, you will, if you want to create the object of this class, what do? You say class will end with a semicolon in C++. Okay. So you see, this is your demo class, and if I want to create the object of this class, you will say the class name and the object name. Understood? This is regular classes, but in this program I have not done that. I have said equals to new because I told you that malloc, calloc, realloc, dynamically allocation of memory shall happen, right? So in this case in C++ we use new keyword. See, in this class you have two things. One is data. Data has what data type? Int. What is the size of int? 4 bytes. Compiler knows this. Understand this. Listen to this very carefully, guys. Listen to this very, very carefully, guys. I am gonna explain you one secret. Why I have to write this node star n equals to new node? I could have created a new node by writing something like this, no? But no, we did not create like that. Why? Understand the concept. This is the node class. I want to instantiate this class. I want to create the object of this class. So what I'll do? I have int data. Int data. Int is of how many bytes? 4 bytes. Because it is primitive data type. Primitive data type means it is predefined in the programming language. So compiler knows. Compiler knows what is the size. 4 is the byte size. Correct? But here you see now next. This was easy. Next you see here node star next. Here node, do you know the size of this node? Do you know the size of this node? Node is the class. One comment came, is this the only way to create objects in C++? Class name and object. Yes, this is the way of creating the objects, but right now I don't have a constructor here. So I did not call that constructor. But imagine that you have a constructor inside this. See here. Let's say I have a constructor called as demo. This is the constructor. This is the constructor of this class. So if I want to call this constructor, what I'll do? I'll go here and I'll say this. This is a constructor call in C++. You got my point? But I did not allocate any memory here because there is nothing that manually has to be allocated. Now listen to this very carefully, guys. Why I am writing new here? You see, this is int data. Inside the class we have two variables, int data and node star next. Right? So int data means 4 bytes. Compiler knows this. So it allocates 4 bytes. But do you know the size of this node star? Do you know the size of this node star next? Node star. It's a non-primitive data type. It doesn't have a fixed size. Understood my point? So to allocate the memory for this guy, we need to dynamically allocate the memory later on. Understood my point? So node star n is the new node, and I wanted to create it as a pointer because it is gonna contain a pointer, next pointer inside. N is the new node here. Remember this. Class name, object name. But inside this node star next doesn't have a memory location allocated. So I have done equals to new and known. Are you getting my point? Alright. Yes, we can. Yes, we can create that like that. But here in your case, we are calling the constructor manually later on. But if you want, you can call the constructor right like this, how I have done, without saying equals to. You are calling the constructor explicitly. But here the constructor is getting called automatically. But in this case, what happens is that I wanted to dynamically allocate the memory also. So I have used new keyword. You understand the point? So now I have created the node. Let's go back to our concept. See here, I wanted to insert a newly created node at the head. So my first job was to create a new node right here. Now guys, see, create a new node. You know how to create a new node? Node star n equals to new node. We cannot use the new to create the object in C++, sir. Please verify that's the only possible. That's only possible in C. One thing, Rishabh. New is different in Java and new is different in C++. This new and that new is not the same. In Java, new keyword is part of object creation as it calls JRE to allocate the memory for the object. Understand the point? New keyword is a reserved keyword in Java which calls the JRE for allocating the memory for that object. But here new keyword is DMA, dynamic memory allocation. That malloc, calloc and realloc that you used to do in C programming is now being replaced by new and delete keyword in C++. So you can also use malloc here. But if you don't want to use malloc or calloc or realloc, as it has become a legacy concept, we are using new keyword. Understood? So see, there are different formats, there are different syntaxes of creating the object. Okay. Now you can create an object like directly like this also, or you can say equals to the explicit call of that object also if it has a constructor. okay, or like this. In this case, what we have done is that we have specified it as a pointer. Pointer has to get memory allocated inside it. So, we are using new keyword to allocate the memory for that object. I hope so this is very much clear. Understood? This is how you create, as simple as that. Okay. Next, here, 1 minute, what had happened here? I guess you see here. So, we created, I want to do inserted head. So, what I will do? I will create a new node. There you go, created a new node. And once I have created the new node, I need to connect this with this existing node. Imagine that linked list does already exist. Okay. So, in this case, in your code, sir, can we use to write, but what happens if you want to allocate the memory? You want to allocate the memory, right? For that you have to use new keyword. I hope so that you are getting my point, what I am trying to say. Rishabh, you have to allocate the memory. Without allocating the memory, how you can create an object? Because it is a pointer, right? N is a new pointer. So, you will have to use either malloc or new in this case. Alright, let us move on. Alright, so next we are creating the node and we want to connect this node. To connect this node, we are imagining this scenario that we are having the already existing linked list in this case. Okay. So, in that case, we have this next node and we have this, and one more thing, inside this class node, what we have done? We have not yet created our constructor. One thing is missing here, guys. We have not created our constructor yet. We need to create our class constructor also, right? So, in this case, we will say node constructor, and in this case, I will have to say here int data, because data has to be accepted, right? And in this case, I will use this of data equals to data and this of next equals to null. Understand my point? Is that clear? So, one thing, I have added a constructor also. So, how will I create the address in this case? Wait a minute. Oh. 1 minute. Okay, everything is in private here. Okay, this is in public, and what happens is now instance of constructor matches the argument list. Okay, here I need to provide the argument, which is val here. Okay. So, in this case, what happens is I have created a constructor, and what I am doing is when I am creating the object here, I am calling the constructor like this, and memory head has the address, no. So, what I will do is I will take up the address from the head into this n, and how? I will say n of next equals to head, n of next equals to head. So, in the code also you see that we have written here n of next equals to head, and at last this will actually connect this linked list to this node to linked list. Alright. So, now what happens here is that This node is connected to this node. So here 2187 and some value is being stored here. Okay. And if I want to connect this with this, and at last I need to make this node as the final node, what will I have to do? What I have to do? I have to point this head towards that newly created node. And how will I do that? If I want to point this node, I need to delete this address and store the newly created address n. Am I correct? So what I'll do, I'll say here head is equals to n. Are you getting my point? This is how the insert at head function was done. I hope so that this is very much clear. Now in the last class I have given you one homework. That homework was write a traversal function. For traversal we are gonna be writing a quick function, and then we're gonna finish up this live session, guys, because there are some technical issues going on right now. Wait, let me just finish up the traversal function also, guys. Okay, let me just give the traversal function also, guys. Okay, so in this case what I'll do is I'll say void display. This void display is what? It's a traversal function. Which is gonna do what? Which is gonna do what? It's gonna traverse, okay, and it is gonna print this whole linked list. So in this case what happens is that we're gonna print this, then this, then this, then this, then this. So how to print it? The idea is simple. You create a temp variable and ask the temp variable to start from the head. So node star temp equals to head. You ask temp to start from the head, and then you ask him to first print the value, this one. Step 1, create temp. Step 2, print the data. Step 3, ask the temp to move to the next node. Ask the temp to move to the next node. Number 3, temp to the next node. And then fourth step, repeat. Create the temp, print the data, go to the next. Repeat. Print the data, next. Repeat until the temp reaches the last node. Are you getting my point? So let's quickly write this function. So we have this void display. What was our first step? Create a temp. So I said temp. What I'll say here? Node star temp equals to start from the head. Node star temp start from the head. Okay, started from the head. Second is print the data and go to the next node, but this has to be done until it reaches to the last node. And this is a repetitive task. If I want to do a repetitive task, what I'll do? I will say create a loop. Once you created a loop, what will happen? You can write that same code inside that loop and run until the temp reaches null. That means you have to say here while temp is not equals to null. While temp is not equals to null is the condition which will take our temp to the last node. Hence when it becomes null, keep on doing cout temp of data. Okay, temp of data, cout temp of data. Print it and then do what? Go to the next node. How you will go to the next node? Temp is equals to temp of next. Understood? What will happen? Start from creating the temp starting from the head. While it doesn't reaches to the last node or null, it becomes null. Keep on printing the data and go to the next node. I hope so that this is very much clear. So this is the function which I have told you to create. Now, if I go back in my main function here, I have done one insertion. Let's do one more insertion. ll dot insert at head, and let's say 20 I have inserted. I will say here copy and paste. This is gonna be 30, 40 and 50. Okay, so 5 insertions I have done. So the linked list will look like 50, 40, 30, 20, 10. Now if I say ll dot display linked list, okay, then what will happen? It will have to print. It will print our 50, 40, 30, 20, 10. This is the traversal function. But it doesn't look nice right now. Why it doesn't look nice? Because there is no space or nothing. So what I will do is I will go back to this function and I will say here, after you are done printing, you will say cout null. Okay. So basically when you print the data, you also print some space, or you can print an arrow like this, and then once you are done doing that, you can say null and then go to the next line and L. Okay. Basically, you have to print the null in this case. Alright. So now you see, when I run this code, you see that it nicely prints like this. This is the traversal function that I had told you in today's class. I hope so that this is very much clear, guys. This is the traversal function which we have done, and this is the insert at head function that we have done. So two things that we have done today: insert at head function, the display function, done. All right. Your homework will be to write the insert at tail and insert at a specific position. And I hope so that today's live session you have understood really well. Alright guys, well I hope so that it is enough for today's live, because there are some technical issues coming with our gear here. So we will continue in the next live. Most probably I will give you the dates. Maybe I can continue in any one day in the week. So let us see. Alright guys, well thank you so much for watching. If you have understood this really well, please tell us in the comment section below, and that's all for this live session guys. That's it. Thank you so much. I can send you the code on WhatsApp on your comment section below, and that's it. So thank you guys. All the notes and everything will be providing in the comment section below, and that's it. Thank you so much guys. That's all for today's live session. I'll see you in the next one. When I'll come to the next one, I'll update in our social media. So don't forget to like, share and subscribe to our channel Code is Arcade, and don't forget to press the bell icon so that you won't miss any future updates, and also follow us on all the social media platforms on Instagram, Facebook, Twitter, everywhere. And that's all. This is Ashank David signing off. That's all for this today's live session. Thank you.